Okay, naive Bayes. So one of the very popular algorithm. Again, this is also very interesting algorithm. It's also classifier. The naive Bayes classifier. So what is the meaning of naive? The meaning of naive is it is not true. Okay. And Bayes means I think if you are good in probability, you will have the Bayes theorem, conditional probability Bayes theorem. Okay. So basically, these two assumptions. One is naive. I'll tell why that is called a not true, and another one is Bayes. Bayes means probability Bayes theorem. Okay, conditional probability. It uses the probability method for classification. Okay, SVM uses the support vector for the classification. Let's see how it is. It is a probabilistic machine learning algorithm based on Bayes theorem with naive assumption. So what is this naive assumption is the input variables is independent. All the input variables are independent. I will tell you what is that. Okay. It has many advantages. One of the advantages, it can work well in the I dimensions. If you have several features, it will work well. And naive-Bayes classifier do good predictions even when the training data is relatively small. You don't need a huge amount of data to train well and then to predict accurately. With a small amount of data also, it will do the classification very effective. So that is another. Another one is it's high accuracy and speed when applied to large data sets. So why it is called naive? It is assumed that each input variable, that is each feature in a data set is independent. So I will tell you what is that. If you take an apple, okay, it is red in color, rounded, and 8 centimeter in diameter. That is the size. Okay. The naive Bayes will consider this color, round, and 8 as independent features. But actually, it is not independent. It's all dependent for an apple. But this algorithm will consider every feature as an independent one. So that is why it is called naive, because it is not true. Considering this value as independent is not true because there is a correlation between the color, round, and size and other features of this apple for an apple, isn't it? So it is true. The true is there is a correlation, but this naive-Bayes classifier will consider as a independent features. So that's the advantage of this. Okay, and it also uses the probabilistic functions, conditional probability. So this is the Bayes theorem. Okay. So we will see how the probability, we will calculate this probability with an illustration. For example, this is a two-dimensional data set. Here your data set has been classified into two. One is yellow dot, another one is green dot. Okay, this is an yellow dot, another one is green dot. So it is classified like this. And you are inserting a new data into this. Okay, for example, you are inserting a new data and you are going to classify to which group this data point will be moved, either to the yellow or to the green. Okay. We need to predict this data point. So this is the new data point. We need to classify whether it is a yellow dot or it is a green dot. Okay, imagine that. That's a new data point. And how it will classify is based on the probability function I said already. So first it will calculate the probability of yellow. The probability of yellow is how many yellow dots in the data set? 1, 2, 3, 4, 5, 6, 7. So 7 by the total number of points is 17. Okay. And the probability of green is all the green dots 1, 2, 3, 4, 5, 1, 2, 3, 4, 10 divided by 17. So we are calculating the probability of yellow and the probability of green dots. Our aim is to classify this dot, isn't it? So imagine that is our aim. And we will have one boundary. Okay. It's a neighborhood region for this dot. So this data point we need to predict, and we will have one neighborhood region, that is a red circle. Okay. So now what we are going to do is we are going to find out the probability of the green in the neighborhood. Similarly, the probability of X, the probability of yellow in the neighborhood, that is P prime. Okay. So this already we calculated. Now we consider the neighboring region. For example, P prime X. X is the data set. That is a new data set. And what is the green? Green is the number of green balls in the neighborhood region. So how many green balls in the neighborhood region? That is 3 by. What is the total number of green balls? It is 10. So this is conditional probability, right? Okay. Similarly, for yellow, we are calculating how many yellow balls in the neighborhood region is 1. And total number of yellow ball is 7. Out of 7, 1 is in the neighborhood. Out of 10, 3 is in the neighborhood. Now, we are going to use that information to calculate the posterior probability. That posterior probability is nothing but P of A, B. Okay. P of A, B. So that is the thing you have to find. So now we are reaching that point here. So the probability of X is green. The probability of this dot is green is nothing but the probability of green, that is the total probability of green, star P prime X of green. Okay. So that is nothing but 10 by 70. So it comes around 30 by 170. Similarly, the probability of yellow is P of yellow and the yellow in the neighborhood. So that comes around 7.1. So which one has the highest probability? Green has the highest probability. So your this dot is considered as green dot. It is joined as, it is classified as green dot based on this probability. So this is called Bayes theorem. Okay. So this is how your naive Bayes classifier will do the classification based on the probability function. Okay. So that's all about naive Bayes. Now you have to understand what is count vectorizer, because what I'm going to do using naive Bayes classifier is I'm going to predict whether the email is spam or not. Okay. So one email is coming. So in our, if you take any Gmail, in our Gmail also, while the mail is coming, some of the mail will come to the inbox, some of the mail will consider as spam. Okay, it is considered automatically. How it is happening based on this function. Okay, so we are going to do that in using the naive Bayes classifier. So for that, one of the important thing you have to know is count vectorizer. So it comes under NLP. NLP is natural language processing. Okay, natural language processing means your machine will able to understand the characters, isn't it? For example, I can talk to the machines. ChatGPT, if you take, we are giving some question, it will give the answer. There, the machine is interacting with the human beings through the language, isn't it? So that kind of applications or comes under chatbot and NLP translation, language translation, Google translation is there. These are comes under NLP. And voice reading, voice converted to the text and text converted to the voice, all comes under NLP applications. Okay, so that is also part of AI. So one of the method in that NLP is count vectorization. There's a lot of things for NLP, and one of the thing is count vectorization. What is this count vectorizer does this? If we have a whole bunch of document, okay, it will take each and every word like this. Okay, so for example, your document has about all things. So these are the words in the document. So it will divide or it will separate all the words, and the number here is nothing but the cent comes 3 times. Okay, the cents comes 1 time, the money comes 1 time. Okay, this is the number of times the words occurred in the document. Okay, and these are the words there in the doc. Right? It will not in the proper format. It is in the form of words. So that's why the naive Bayes is very, very useful in the language processing, because it is not considering the relationship between the words, but it will analyze the word, but it will not consider the relationship between the words. When you read this, you will not have any meaning, because all the words are considered as independent. So that's how the count vectorizer will work. So we can apply the naive Bayes for this kind of applications, isn't it? So that's why I'm using email to detect the email, whether it is a spam or spam. So I think you have understand these things. So each word, if you have any document, the count vectorizer will convert the document into words, and it will count the number of times the words occur in that document also. Okay, so with that information, we can work on the naive Bayes classifier. So it's very interesting application. So far, we are calculating the prices and the classification like that. This will be different. Okay. And you can learn a lot of new things in this application. But the concept is same. You can use SVM for classification. So the same credit data you can use for this also. If you use this one, that is also fine. But we can use different applications. For learning purpose, I'm choosing this. If you want to use this algorithm for the same credit data set, you can use. Only thing is, the same method you can follow. Okay. Now we will begin the naive Bayes. As usual, importing the libraries. I've included one more thing called Cborn here. You may know what is that. Okay. Pandas for handling the tables, NumPy for array, Matplotlib for plotting the data, plotting the tables. What is the Cborn? Cborn is also a you can have the statistical graph, for example, bar chart, all those things we can use above Matplotlib. If you are using Matplotlib, if you want some fancy charts, okay, from statistical charts, then you can go for Cborn. Okay, with the colorful charts, if you want some colorful chart means definitely you can go for Cborn. So I'm just connecting my notebook. First, upload the email. So it is it's a big document. So it may take some time. So I'm taking this .csv file, and it will read using the pandas library function, and it is stored in the data set. So you can see here, it is loading. So it is taking some time. We have to wait. So below that, you will have some details. So it just for learning purpose, I'm included here. So dataset.ed 10, that means first 10 data in the data set will be displayed. Tail means last 10 data. Okay. Describe means you can see the values, maximum value, minimum value, standard deviation value, all those things we can see. Okay, this is the information. Information means how many rows, columns, all those stuffs we can see. So let's see. Okay, so now it is uploaded. I'm just running the code. It's done. Now we'll see the data, isn't it? Now we can see here your data set has 3 columns. If you open the email CSV file, it has 3 columns. Starting from 0, it's an index number, and you have the subject of the emails. Some of the emails are genuine. that is called AM. And some of the emails are spam. Okay, so this is a text of the email subject. And spam, the last column, 1 is representing the spam and 0 is representing ham. So that means it is a genuine message. Okay, so you can see now it's the spam. The stock trading, gunslinger, something is there, no? Color printing, special request, don't have money. So these kind of things is considered as spam. And the research and development charges. So somewhat meaningful data are considered as zeros. So let's see. How many rows are there? 5,728 rows. So that means 5,728 mails. Okay. And 2 columns. One is text column, another one is the output spam column. Then just execute this and you can see the first 10 is coming out. 0 to 9. Always it takes the values from 0 to 0. And you can see the last 10. Okay. So these are the last 5,727. Describe. So you can apply this for all the data set. Okay. Irrespective whether it is a text or it is a number, you can apply. Here you can see the count is 5728. Mean, standard deviation, mean. This is calculated for spam. Okay. Maximum value is 1 because it is either 1 or 0. It's a classification of that. And information. You can see there is no null. So there is no empty rows. Okay. All the rows are with the data. Memory is 89.68. That's a huge data. Okay. So these are some of the things. If you want to analyze the data set quickly, you can use this kind of course. Now I want to visualize the data. So visualize the data means I want to see what are the spam data, what are the ham data. Okay, so that's the visualization part. So here you can see the data set spam 00. It is nothing but a Boolean operation. Spam 00, spam equal to 00 means the text is not a spam. Okay, that will be stored in the ham variable. It's a genuine data. Okay, if you run this, you can see, if you want to see that ham, it's like ham. You can see all the ham will coming out. Okay, so how many data are a ham in the email data set is 4,360 rows are hams or genuine messages. Okay, and if you want to see what are the mails or spam, then you can go to the code part and the spam data set. Okay, so when the spam is equal to 1, then that part will be stored in the equal to 1 in the data set will be stored in the spam. Again, run this and run the spam. You will have how many datas? Check it out. 1,168 rows are spammed. Okay, so you can see the spam mails. Would you like to get $250? Just to click it, you will get 1 lakh rupees. So these kind of things are spam mails. So it is classified. Okay, so this is from the data set. We are not creating the model. We are just analyzing the data set. Now only we are entering into the pre-processing. Okay, so far we have just analysis the email data set. Okay, now we are going to apply the count vectorizer. So there is some more points will be there. The percentage of spam and this percentage of look at here. So this is this part of code SNS. I already told SNS is for graphical representation of your data. Statistical, it gives the statistical information. So you can see SNS, spam from the data set. Okay, title, category, everything we are given. Okay, so there is this a part of a code. Okay, you can just use for anything. Only thing is you need to change the variable name. That's all. And you can see ham mail is around 4,000 and spam mail is around 1,300. That's the purpose of SNS. Okay, we move to the important part of the code, that is count vectorizer. Now we have to carefully see how the data has been converted. Now you can see now it is from the sklearn feature extraction text. Okay, this is used for text, means it is used for language processing, natural language processing. And count vectorizer. So I told what is count vectorizer. And we are creating the model in the vectorizer variable, and we are training the vectorizer with the data set text. The text is the content of the mail, okay, from the data set, and we are transforming and we are training that using the vectorizer. That is called spam am count vectorizer. Okay, just the same process, but different. Okay. Now you can see your text has been converted into count vectorizer format. Okay, just we will have some print and see what is this value. So if you want to see the vectorizer, you have to use this code. Okay, just a correction. So we will see vectorizer dot get feature names out. So this is the, you can see now 0, 0, 0, 0, 0, 0, 0, 0, and some dots. That means the length is very huge. Okay, and then Z, Z, N, like that it is going on. Okay, the last word is 4Z. The first is 0, 0. So all the words and all the data in the mail has been classified into individual words. Okay, in a document there will be a lot of words, all will be captured into a individual document, individual words. Okay, now we can see the shape of this one. So what is the shape of this one? From that we can easily understand how many words are there. The entire data set. In the entire data set, we can see it has 5,728. Okay, so that is the entire data set rows. Okay, and what is this 37,303 is the different types of words. That is nothing but 00001, like that 000. So 37,303 in the total 5728 mails. Okay, so now imagine it is in this format. Okay, I explained in the PPT. So it is in the format. Okay. After that, I'm going to split the data set for training set as well as test set. Here also we are doing the same thing. Okay. So look at here. So the data set spam. So what it means? Data set spam means in the data set, the spam column alone is taken in the label. Okay. So this is the column name. So you can, if you want the individual column, you can use this method also. So if you have lots of columns, if you want to separate that column and store in a variable, then you can use this type of. And x equal to spam ham count vectorizer. So what is spam and counterizer vectorizer is nothing but the text. Text has been applied into the count vectorizer. Now in the form of count vectorizer, we are the X has the values of text after applying into the count vectorizer, and it's a label. Now you can see the shape. The shape will not change, and for Y it is 5728 shape. Okay. Now we are going to divide into two, test set as well as data. So you can see now train space with X, Y. What is X? X is the text column and Y is the spam 0 or 1 column. Okay. After that, test size I am giving as 0.2, that is 20% of the data. So I'm just running it. Now your data has been split into training set as well as test. Next step is training the naive Bayes model on the training set. So some interesting parameters is there. You have to learn. sklearn naive Bayes import multinomial NB. Okay. So you just see from the, if you type sklearn naive Bayes on the Google, you can go to the particular point. Here you can see lots of things. Gaussian naive Bayes is there, multinomial is there, complement is there, Bernoulli is there, category naive Bayes is there, out of core naive Bayes is there. Okay. So you can choose any one of this. Basically, Gaussian they will use for probability. They will use for values. For example, if you want to use credit card or estimating the social ads. Okay. So in those cases, when you have only values, then you can go for Gaussian. Okay. So for that, and if you want to use text and Gmail like that, means you can go for multinomial NB. Okay. These changes you have to make when you are using the values as well as for the Gmail text classification. Anyway, it will do the classification, but usually they will use multinomial for text and Gaussian for numbers. So you keep that in mind. So multinomial, again, we are creating a model. We are fitting that with X train and Y train. I'm just running it, and the model will be created. Now I'm going to predict the values with the X train. I don't need to predict with the X train. Okay, it's not needed at all because it did not give any information for us. No need for that. We will actually do the evaluation with the test, isn't it? So it is already trained. So no need to test the data with train. So we go to the metrics part. The accuracy score and confusion matrix, the same part of the code. And I'm going to predict the values for the X test. So X test is the 20% of the data I'm going to predict, and the result will be stored in the predict test. Okay. Now I'm adding one code to see my test. So it is in the form of arrays, the single dimensional array. So you can see this is the output of the predicted output for the X test. Okay, this is the test, and this is the predicted output for this. Okay. After that, the final part of this one is we have to find the accuracy score, isn't it? So confusion matrix and accuracy score. I'm just giving Y train and Y predict train. Actually, we cannot give like this because we are focusing on the test. So Y test. So just make a change over there. white predict test. Similarly, white test, white predict test. Now we can see 98% accuracy is there for the naive base for this algorithm. And if you want to see the confusion matrix, CM, let's check out. So 866, 266 correct. So only 14 mails out of 5,000 is predicted wrong. So that means a 98% accuracy is achieved using naive base. Very good. After that, I'm just predicting the result. For example, I'm going to give one mail. Okay. And I'm going to check whether it is correct or not. You can check it. So now you can give any data. Okay. For example, hi, how are you? Okay. So this is meaningful only. And I'm checking it. Say you can see the email is predicted to be a ham. Ham means it's a correct message. So how this will happen? That hi, how are you has been passed into the vectorizer. Again, it is classified into word format, and then it is converted into a number because the machine learns only the number. So that is the use of count vectorizer. So in the you can see now. So this is in the theory. So all the words has been converted, and the number of occurrences here. But actually, what the algorithm does is it will not see as about. About is represented as a number. Okay. Okay, converted into numbers. So your machine learn converts this hi, how are you into numerical values, but it has some meaningful words inside that. So that is the beauty of vectorizer. And then again, it will predict whether it is in the classifier, it will predict whether it's a spam or ham. If the prediction is 0, the email is spam. If the prediction is 1, the email is ham. For example, we can give some other thing also. Okay. That's how the message will come attractively. Okay. Stick it. Here also it is considered as some meaning is there. Click to win 1 lakh rupees. So you can try some other words. You can see from the data set also. It's too large. Okay, any number you can give. So also ham. I'm giving some random. Okay. Everything is taken as ham. Okay. So I'm going to email because 98% it is correct. So I have to give proper spam mail. Okay. So I am copying this. You can try with any messages. Just I'm trying out, that's all. There is also am. It's coming am. Okay. What is this? Okay, so you can check with the different things. I want it to be spam because when you are giving spam, it has to come spam. Okay. Okay. So there will be some wrong prediction here. Okay. So that's how it will work. It will work properly. There will be some issue here. Okay. In the predicting point. The code part is right, but prediction is not happening as we expected. Okay. So that's all. That's how the text class, but the accuracy is 98%. So you can try with different values, rerun the code, and then you can try also. You will get the output. So this is how your email has been classified into spam as well as okay. Okay, so that's all. One more thing I want to share. So you can use this name base for credit vector also. Okay, so I told that already. So if you want to do that, uh, take the support vector mission algorithm. You can compare the result of a naive base as well as support vector machine. And one more is there, that is logistic regression. Three classification algorithms we have discussed. You can use the same data set in all the different algorithms, and you can see which one is performed better. Okay, based on that also, you can come to the conclusion for this particular data set, this algorithm is useful. Okay. So now, this is the data set for SVM. So we created for SVM the same thing. Only thing is I'm going to change here for the naive base. So how I'm going to change this? Let's go to the code part. So I'll finish with this. Count vectorize is not needed for that. So this is the part. Okay. And here you have used SVC. Okay. I'm taking this as classifier. Here also classifier. X and Y and all the things are same. Okay. Here I don't need to give any kernel because there is no kernel for thing. Only thing is I have to use Gaussian NB. That's the one thing. Gaussian. I'm just deleting this part. It's not needed now. So that's what. Okay. Now we can run it. It's not a support vector machine. It's a naive base. Okay. And what is the accuracy we have get for this one? It's 95. Read data, same data set, same method. If you want to run all, you can give run all, no problem. So it will run at a time. If it is any error, you can so look at here, it converts them to Gaussian, and the result is 97.97.2. So that means naive base is performed better. So now imagine I want to give multinomial NB. You can check it out. Multinomial NB. So this is how you can analyze the algorithm, and you can let's check it out. How it performs. Okay. So see that it pauses the error. If I use multinomial, it's answer. So you want to check what is the error. Okay, we'll go to ChatGPT. So this is how you can learn the algorithm. So ChatGPT is very useful. I'm posting my error, and it will give you what is the reason for that. The error you are encountering when you are trying to fit the model. Okay, so it's giving something. But you can see what is the reason. It's usually multinomial labels is used for discrete data where the feature represents counts or frequencies. So that is text classification. When after applying the vectorizer, your data is a discrete data, then you can apply the text, apply the multinomial. You cannot apply multinomial for values. So that's what the error says. So it will not work. So that's why we have to use Gaussian when you are analyzing with the data. Okay. So that's what I want to explain. That's how we can use the ChatGPT. You can use ChatGPT when you face any errors. So with that, I'm winding off.